When we talked about measures of variation, we talked about standard deviation being the most useful. So in this video, we're going to look at using the standard deviation to look at some statistics. The first thing we're going to look at is the z-score or standardized value. We'll use this a little bit this week, but we'll come back to it later in the course. The z-score is a really important concept, especially for those of us in healthcare. What the z-score tells us is how many standard deviations a value is from the mean. So again, we have two formulas. The z-score is x, the data value, minus the mean divided by the standard deviation. Our second formula is the same concept but for the population. So the z-score is x, the data value, minus mu, population mean, divided by sigma, population standard deviation. For this course, we're going to round to hundredths because that's the table that we have in the back of our book. The rounding will vary by course and by the tables used, but we're not going to worry about using the table yet this week. We're just going to worry about the concept. What a z-score tells us is that if the z-score is higher, it is a relatively better score in the data set. Let's take a look at an example. We have the data of the number of nurses per 100,000 people for the states that border Pennsylvania, including Pennsylvania. Previously, we found the mean of this data, and we found the standard deviation for this data. So let me look at Delaware. Delaware had the most nurses per 100,000 people in this group. So I take the data, x, I subtract the mean, and I divide by the standard deviation. And I get 1.49. This means this is approximately 1.5 standard deviations above the mean. I know it's above because I get this positive value. So if I took the mean, the 959.4, and added a standard deviation, and that added half a standard deviation, I would be at the value for the number of nurses per 100,000 residents in Delaware. So let's look at the low end. In New York was our lowest number of 848 nurses per 100,000 residents. So I take that data value, subtract the mean, take my answer, divide it by the standard deviation, and I get negative 0.85 standard deviations from the mean. This negative indicates that my data value was below the mean. It's not a full standard deviation below the mean, so it's less than 131 nurses below the mean. And so as I look at these two values, a higher z-score, so the positive one is the higher z-score, is relatively better. It's more nurses per 100,000 residents than a lower z-score. Z-scores also come into play with the empirical rule and the normal distribution. We're going to look at the normal distribution later in the course, but the normal distribution is when the histogram gives us this bell-shaped curve. This bell-shaped curve shows up a lot in healthcare. It shows up whenever something is biological, which is people, and all the different measurements like pulse and temperature and blood pressure and heart rate and all those different things about people. When we have a normal distribution, the mean is right in the middle, and the data is clustered around the mean. So from the mean, if we would subtract out one standard deviation, and from the mean, if we add one standard deviation, this section, this peak of our data, ends up being 68% of all of the data. And then if we take our mean and we subtract out two standard deviations, and then we also add two standard deviations, we get this bigger section, and it ends up being 95% of the data is within those two standard deviations of the mean. Finally, if we take our mean and subtract out 3, so from our set, this would be minus 131.1, minus 131.1, minus 131.1. And going this way, the mean plus 131.1, plus 131.1, plus 131.1. Within 3 standard deviations, we get 99.7% of our data. So this leads us to the rule of thumb. And the rule of thumb is telling us what values are unusual values. So The minimum usual value is the mean minus 2 standard deviations. Maximum usual value is the mean plus 2 standard deviations. If we go back a slide, so right here where we subtracted out 2 standard deviations from the mean, that is the minimum usual value. All of the values in here are usual up to this point where we added 2 standard deviations. So it's just a way to sort of estimate, are values outliers or are they relatively normal? And so usual values we're giving as 95% of the data is usual. The top 2.5%, the bottom 2.5%, those are unusual values. We can state this differently, but it means the same thing, doing the same math. Usual values will end up having a z-score greater than -2 and less than 2. When we do the z-score formula, take the data minus the mean and divide by the standard deviation, any value bigger than -2 up to +2 indicates that that is indeed a usual value. So let's look at some examples of this, and we'll go to Minitab for that. So in Minitab, we have this nurse data that we've been working with, and we had previously run our statistics with this nurse data. And so I know for all of the nurses, we see right here for all the nurses, that the mean is 900.8, and we see the standard deviation of 183.9. We also, when we did that, asked for the minimum and the maximum. So the first thing I want to do is just say, is the minimum an unusual value? So in order to do that, I'm going to use the z-score formula. So in order to find the z-score, I'm going to use my formula z equals the piece of data, and we're going to do the minimum, 585, subtract the mean, and the mean we had as 900.8, and divide by the standard deviation, which is given to us as 183.9. So I do that on my calculator, and I get a value of -1.72. So by our rule of thumb, it says usual values have a z-score greater than -2, less than 2, and that is true. So this minimum is a usual value. Let's try it again for our maximum. So in our data, our maximum, z equals 1483. That's our data value, our maximum data, minus the mean, divided by the standard deviation. Again, I go to my calculator for that value. And this time I get an answer of 3.17. So when I look at my rule of thumb, this is definitely greater than 2. So the first one was okay. It is usual. The second one, however, is unusual. Might be an outlier, too far away from the data. Well, now I have a question. So I have the maximum that is unusual, but do I have other unusual values? So I'd like to know, what is the maximum usual value? And so this rule of thumb gives me a formula. Take the mean, and so we have our mean of 900.8, and we're to add to it 2 of the standard deviations. And our standard deviation, 183.9. So I go to my calculator, and I get 1,268.6 maximum usual value. Now I'd like to look at my data and see, are there any other unusual values? I know that the maximum of the entire set is unusual, but are there any other unusual values? So I'm going to look at a bigger picture in Minitab, and I'm going to actually sort my data so that I'm not scrolling through all of these numbers, but I can put them in order. So I go to Data, and I click on Sort, and I would like to sort all of the data together. So I want to sort the state, the doctors, and the nurses. I don't need to sort my smaller data groups. looking at the nursing data, so I would like to sort it by the nurses, put them in order. And so all I need to do, it's going to come up in a new worksheet. Okay. And in my new worksheet, I now have, instead of having the states alphabetical, I have the nurses from the smallest up to the greatest. So I'm going to scroll through them. And here I have largest amount of nurses per 100,000 people. And we had calculated that anything above 1,268.6 would be an unusual value. So when I look here, Massachusetts, that's still a usual value. But South Dakota, that is above our maximum usual value, and District of Columbia was the one we had done before, is an unusual value. So that's how we can use the rule of thumb to determine if there are usual or unusual values, and within that we are using the concept of standard deviation. Next we're going to look at the coefficient of variation, or CV. This compares the standard deviation to the mean and gives an answer as a percent. A higher percent indicates greater variation among the data. Again, the formula is given twice, same concept, just once for a sample, once for the population. We're going to round it to the nearest tenth of a percent. The coefficient of variation is really helpful when we're looking at different data sets. So again, we're going to go back to Minitab, and this time we're going to look at the doctors and the nurses. So I'm going to move to my original worksheet. So I'm back in my original data. And I had descriptive statistics for nurses, and now I would like descriptive statistics for the doctors. So I'm going to go to Stat, Basic Stats, Display Descriptive Statistics. I want doctors this time. And the statistics I want the mean, standard deviation, variance. These are all the things we checked before, so okay. Okay again. So now I have mean and standard deviation for the doctors as well as mean and standard deviation for the nurses. The means are very different. The standard deviations are very different. So to compare these two different sets, what I want to use is the coefficient of variation, or CV. To calculate the coefficient of variation, first going to do the nurses. So this is CV. I'm going to use a little n there to indicate that this is the nurses. And I take the standard deviation, so here's my nurse data, standard deviation 183.9. I divide it by the mean, which is 900.8, multiply that by 100 to turn it into a percent, and put that on my calculator. And I get an answer of 20.4. Again, I'm going to repeat this just with the doctor's information, so the coefficient of variation for the doctors. The standard deviation here is 101.1, the mean 275.5, change that into a percent, go to my calculator, and I get 36.7%. So this allows me to compare the two different populations. With the higher percentage for the doctors, there is more variation in the number of doctors per 100,000 residents than there is in the number of nurses per 100,000 residents when we compare the different states within the United States.